This is lesson 12.5 on equations of circles. So just like we could write equations of lines given, for example, 2 points or a point on the line and a slope, we can write the equation of a circle if we know its center and its radius. So if you're in Algebra 2, you probably have already learned this. If you're not in Algebra 2, you'll do this next year in Algebra 2, and then also you'll be using it pre-calculus and beyond. Sometimes this also shows up on standardized tests. So this is not the greatest picture because I don't have the actual graph paper showing in the background, but hopefully this is good enough that you can kind of tell what's happening. Okay, so we're going to try to figure out, here's the equation of a circle. We're going to kind of try to figure out what things are important about that equation. So notice the center of the circle is at 1, -3. Okay, that point right there is 1, -3. The radius is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so in all directions from the center, the radius is 4. For the second problem, so the center appears to be, here's the equation of the circle. Okay, the center appears to be at 1, 2, 3, -4, 2. And the radius is 1, 2, 3, 2, 3. The radius is 3. Okay, so hopefully this is obvious what the pattern is here. So we're looking at the radius is being used over here. Same thing on the second problem. The radius is being used over there. So that number on the right side is apparently the square of the radius. And then I want you to notice that the 1 is showing up with the group with the x, and the -3 here is showing up grouped with the y, except that it appears as though it changed signs. That also happens on this one, right? -4 became a +4 for the x, and then a 2 became a -2 for the y. It's kind of like when you do point slope form, how it appears as though the sign of the number changes because the formula has a subtraction in it. So for this last problem then, if you cannot tell what the radius is, let's just count the diameter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if the diameter is 12, that means that the radius is 6. Now, where is the center? Well, if the radius is 6, it's going to be 1, 2, 3, 4, 5, 6 down. So that's that point right there is 0, -3. And the center, so it would look like x minus 0, and then y plus 3 is equal to 36. Now we don't have to actually have the 0 there, so we could just write as x squared plus y plus 3 squared is equal to 36. That's kind of common to just leave out the 0 when the center lies on one of the axes. Okay, so here's the standard equation of any circle. The equation of a circle with center HK and radius R is parentheses x minus h quantity squared plus y minus k quantity squared is equal to r squared. So we'll have the center HK is going to show up with the x coordinate with the x, the y coordinate with the y, and the sign will have changed. So notice that these are minuses here. Okay, and then the radius is being squared on the other side of the equation. Now, this is basically the distance formula. If you find the distance between a point HK that is the center of the circle and then a point XY that lies on the circle, okay, you could say the distance between them, that would be the radius, right? So you have a circle and there's the center. You want to figure out the distance between the two. That would be the radius. So the radius would be, put that point there. This would be your HK point. This is the center. Okay. Your equation would go x minus h quantity squared plus y minus k quantity squared is equal to the distance. Let me write this way, the distance, and then that would be the square root of that. Okay, the distance formula says the square root of the difference between the x's squared and plus the difference in the y's squared, and that gives you the radius. So basically, if you square both sides, then you have that equation. Okay, so the equation of a circle is really just the distance formula. So also that means that every point on the graph of the circle will make its equation true. So let's just check that, for example, for this problem, a nice simple calculation here. So the point 0, 3 is on the graph, which means it should make its equation true. So when you put that in to that equation, it should say, let's see, 0 is going in there. So 0 minus 0, quantity squared, plus 3 is going in there. 3 plus 3 quantity squared. Is that equal to 36? Well, that's 0, right? And that's 6 squared. So it checks. Any point that satisfies that equation would actually lie on the circle. We're not talking about the center of the circle or an interior point like in here. We're talking about it being actually a point on the circle, which is something that's on basically the circumference of the circle. Okay, so nice simple examples here. We're not going to get too in depth in this. So the center would be the point 3, negative 2. The radius is the square root of 4, or just 2. Okay, so to graph it, you'll plot 1, 2, 3, negative 2, and then a radius of 2. 1, 2, 1, 2, 1, 2, 1, 2. And then draw our circle. Beautiful. Okay, for the next one, your center would be the point negative 5, positive 2, with the radius being the square root of 1, which is 1. So 1, 2, 3, 4, 5. Negative 5, 2 is placing us right there. And our radius is 1. So right 1, left 1, up, down, down, down. Right 1, left 1, up 1, down 1. Okay, there's our circle. Okay, just a few example problems here. Find the equation of the circle with the center given in the radius. So this would go x plus 4 quantity squared plus y plus 6 quantity squared equals 49. Okay, for the next one, it would say x minus 1 quantity squared, y plus 3 quantity squared is equal to 100. The right side is the r squared. Okay, so if we started out with a circle that's centered at the origin and we translate it, it's not going to change the radius. Okay, the radius is going to be 5. It's still the same size circle. It's just that we moved it. So instead of being at 0, 0 like it was, we're going to go to the right 2 and down 4. So if we do that, we're now at the point 2, negative 4 for the center. And that means our equation would be x minus 2 squared plus y plus 4 squared is equal to 25. For the next problem, we're given a circle and we're asked to translate it. So if we were sitting at the origin and we went right 2 and down 1, 2, 3, 4, we would now be at the point 2, -4. That would be our new center. Okay, so that means our equation is x minus 2 quantity squared plus y plus 4 quantity squared. And our radius didn't change, so it's still going to be equal to 25. Our radius is 5. Okay, for the second one, x squared plus y squared equals 100. We're going to move it down 5 units. So if we started out at the origin, which by the way, these are like x minus 0 squared and y minus 0 squared. That's how I know we started at the origin. Okay, so if I started at the origin, I went down 1, 2, 3, 4, 5. That means my new ordered pair for my center is 0, -5. So our equation would say x minus 0 squared plus y plus 5 squared is equal to 100. Okay, we did not change the x. We moved it down 5, so we did change the y coordinate. On the previous one, we changed both the x and the y. Write an equation for each circle. Okay, let's see. 1, 2, 3, 1, 2, 3, 4. Looks like that point is at -3, 4. And it looks like our radius is 1, 2, 3. So equation of the circle, let's say x plus 3 quantity squared, y minus 4 quantity squared, and then 9 on the other side of the equation. Okay, looks like over 2, down 1, 2, 3, 4, 5, 6. So that point is 2, -6. And it looks like the radius is just 2 units. So x minus 2 quantity squared, y plus 6 quantity squared equals 2 squared, or 4. Okay, and then just for practice, go ahead and write down what your answers are for A and B. Pause for a second, write them down. Okay, and then your answers should be the center is at 3, -1. The radius is 6. For the second one, the center is at -3, 5. And the radius is 9. Now, this number over here is not always going to be a perfect square. So if you had something where it was equal to, let's say like 18 or something, then you would say your radius is the square root of 18, which is 3√2. Okay, so you'll leave your radius as a simplified radical.